So now let's switch to some design patterns. Our next speaker, Ignacy Sokołowski, he is a Python developer who loves simplicity, clean code, fast unit tests, and good documentation. Ignacy is also an active member of the PyWaw community. He will discuss the first of the solid object-oriented design principles, and that is... Yes. Please welcome Ignacy Sokołowski. And you've got a t-shirt.
Okay, so that's right. I'm going to be talking about the single responsibility principle. So what it is, it's a principle which states that every class, every method, and every function should be responsible for only one thing. And where did it come from? The term single responsibility principle was first introduced by Uncle Bob, Robert Martin. And it's the first of 5 solid principles. Solid is an acronym of acronyms for 5 basic principles of object-oriented programming. The first one is SRP. Then we have open-close principle, Liskov substitution, interface segregation, and dependency inversion. I'm not going to talk about all of them today. I'll just focus on the first one. But maybe I'll mention some of the others while showing some examples. The single responsibility is, this principle is followed also around us in real life, not just in programming. So take, for example, a car. A car is built of many different components. It has an engine, it has a gearbox, a braking system. But each of these components is responsible for a different thing. The car talks to these components. It tells, for example, the engine when to start, when to stop, but it doesn't have to know how the engine works. The engine is also replaceable. You can replace an engine in a car. You can change it to a different one, and also you can use one engine in many different cars, because the car just talks to that via some interface, but it doesn't have to know how it works and which of the engines it uses. Another example is a company, like the company I work for. We have many different departments. We have developers, we have sales department, we have support, and each of these components is also responsible for a different thing. So as a developer, I'm responsible for building the product, but I don't know how to sell it, right? Because that's the responsibility of the sales department. And they sell the product, but they know how it is built, because that's not their responsibility. Here's an example, not maybe from real life, but that's an example that we all know, an MVC web framework, like Django or Ruby on Rails. So if you have an application, an MVC, an application that uses an MVC web framework, then you have 3 different layers. You have model, view, and controller. And each of these layers is responsible for a different thing. So for example, if you'd like to change the layout of your website, or if you'd like to change a color of a link, then you touch only one of these layers, the view layer, right? You don't have to change the controllers nor the models, just the presentation layer. Okay, so what does it mean to be responsible for only one thing? It doesn't mean just to do one thing, because you can have a function that does many different things, but it's not responsible for all of them. So say you have a function that sends email reports, so it has to get the data for this report from some database probably. Then you have to format the report, and finally you send it to you send it via email. So you could have one function send email report, but you will also have 3 different functions prepare data, format data, and send email. So this top-level function just invokes 3 different functions. So it does more than one thing. It does 3 different things, but it is not responsible for how they are implemented. This function would be responsible just for one level of abstraction. So just sending email report is one level of abstraction, but in order to send email report, you have to perform 3 different tasks on a lower level, right? So you have to get report data, format the report, and send it via email. So that's 2 levels of abstractions. But to get a report data, you have to perform 3 different tasks on an even lower level. So you have to build an SQL query, you have to send it to a database, and then you parse the result on data objects and you return it from the function. So you have 3 different layers of abstraction. You can have even more of them. So that's how you would represent it as a Python function. You have a function called send email report. It calls 3 different functions: get report data, format report, and send email. But it is not responsible for how they are implemented. It just knows that it formats the report, but it doesn't know how the report will be formatted. And that's just one level of abstraction. It doesn't go any deeper. Uncle Bob describes a responsibility as a reason to change. So one class should have not more than one reason to change. So if you'd like to change the way reports are formatted, you should not change the class responsible for preparing the data, nor the class for sending emails. If you'd like to change the database for articles in some blog web application, then you should not touch the controller for displaying the articles. It should not know where the data is stored. So what are the advantages of systems following the SRP? First is readability. If you have one function that inside of it has like 10 lines, each responsible for a different thing, 3 lines for getting the data, then 5 lines for formatting the report, and so on. When you're just interested in formatting the report, you still have to read the rest of the lines, right? You're distracted by the surrounding code. You can't just focus on one thing. On the other hand, if you had 3 different classes, you have a report formatter, you read it, and you're just focused on formatting the report. And it is abstracted from the context in which it is used. And you also name the responsibility. You have a class called report formatter, and you know what it does, because the name of the class tells you. Another advantage is maintainability. So, for example, if you change the name of a variable, if one function, it doesn't influence the other function. So it's a smaller risk to break a thing when changing another one. Reusability. If you have one object that is abstracted from the different contexts in which it is used, you can use it in many different contexts. So if you had a class for sending email messages, then you can use it to send many different kinds of emails, not just report emails, but also like registration emails and many different kinds. And also you could extract this class or the whole module into a separate library and use it in many different projects. So it's really reusable. And finally, testability. It's a lot easier to test a class or a function that is responsible for one thing. It's easier to test it in isolation. Because if you had one function, this function with 10 lines of code, which does many different things, if you'd like to change all of these things, you would have to execute the whole body in your test, the whole body of the function. Even though you want to test just sending email messages, you still have to execute the code that touches the database and so on. So it will take a long time to run a test. You could, of course, mock it, the code that you don't want to use to be executed. But then if you have many different tests, all for the same function, each of these tests will have to use similar mocks. And then when you change one thing in this function, then you have to change all the mocks for all the tests. So testing becomes painful, and you stop writing tests because it's just too much overhead. It's too much testing. Okay, so here are some code smells. If you see that your code smells with some of them, it means probably that something's wrong with it, and probably it breaks the SRP. I'll show you some examples of these code smells. Here's the first example. Here we have too many local variables. It's a function that validates some signature from an XML. It's not so easy to understand it at first sight. So let's count the local variables. We have 1, 2, 3, 4, 5 local variables. Let's try to make this function a little bit more readable. First, I'd split the code into different logical sections and put a blank line between each of these blocks. So now I can see that in the first block, I just get some data from the XML, and then I do something else. I don't know yet what, but that's for sure another step. But that's a code smell, sections within functions. If we have one function and we need to split it into different sections, then probably that's something wrong. So when we know what the second block of code does, we can put a comment above it, describing what's going on in the second step. So now we know that in the second step, we calculate valid signature. And then we compare the valid one with the one from the XML. But if we have a separate section, and even we can say what it does, then probably we can extract it to a separate function, like here. We have a function called calculate valid signature. We get rid of this comment. We replaced the comment with a function name. And now the first function, validate signature, is a lot more readable. It just calls this function. You know what it does, but you don't have to know how do we have to calculate the valid signature. And it is not responsible for that. So we can calculate valid signature in many different places in our code, and also it's a lot more easier to test because it no longer accepts the XML argument. So in your test, you don't have to pass an XML to it. Here's another code smell. We mix a data structure with an object. We have a user class with a method for sending reports. That's quite a long method. It's too long, but there's something other that bothers me. Because should user be responsible for sending reports? Probably not. He should be just a data structure. It should be an object that stores some data about the user, like username, password, first name, last name. It just should store the attributes. And the action of sending reports should be extracted to a separate object, which is responsible just for sending reports, and it accepts the user as an argument. So now we have an email reporter. We know what it does, but the method is quite long. It does a lot. Let's try to understand what's happening here. So first we prepare some email subjects, so probably we will send email messages, email reports. Then we get some offers from database, so that's probably a part of the data for report. Then we have a template path, template context, and then we use these variables to render a template. So probably the report will be formatted as an HTML document. And then finally we connect to an SMTP server and we send an email message to it. That's too many responsibilities. If I'd like to change the way the offers are looked up in a database, we would have to touch the code for reporting, right? If we'd like to change the way we format the reports, we would also have to touch this class. So it has more than one responsibility. Let's extract it. So the first step would be just to define a structure for reports so that I could see what data is stored in a report. So I have a class called report. It just stores the attributes. It is just a data structure. And I have also extracted a class called period. Maybe it should be time period. It stores 2 dates. Because I have noticed that in this function, I accept 2 different days, but they also go together. So I could just put them in one object and pass them along the functions as one object, as one argument. Okay, so I need a class for preparing the report, having those arguments, user, category, and period, the same that I needed here. The report needs some offers, so I need to find the offers. So this function prepares a report. It returns a report instance, but it is not responsible. It looks for offers, but it is not responsible for how we look for the offers. We have a separate object called offers finder, and we don't even know what is this object. This class is not responsible for defining the class for finding the offers. Here we have this class, offers finder. It's quite simple. It just executes some query from database and returns offer objects. So now if we'd like to change the way we look for offers, we just change this one function. We don't have to change this function because it's not responsible for finding the offers. And if you'd like to change, maybe we would like to search for offers sometimes in database and sometimes in, say, some cache. Then we could implement a separate class, separate offers finder with the same interface with the method find, which accepts category and period. We could have a separate class and sometimes use one and sometimes the other. And we just pass it to this constructor of report preparator. We don't have to change it. Okay, so now we have this report preparator. This method for sending reports is a little bit smaller, but there's still too much happening here. So let's extract a class for formatting the report. We have HTML report formatter. It has a simple interface. It has a method called format, and it accepts the report argument, right? So we no longer have the 3 different arguments in 2 different classes. We just have this report object. And it is responsible just for rendering an HTML template. And now if you'd like to change the way we format reports, we just change this class. Or we can have, for example, a PDF report formatter and use it instead. That's how it looks like right now, the email reporter. It's no longer responsible for formatting reports. But it's still responsible for preparing the email message and for sending it, and for defining the subject for an email. So let's extract it. I have a report email preparator. It just prepares subject and body and returns an email message. And I have also moved the report formatter here, so it can accept just the report argument. Now that's how it looks like, the email reporter. It's now responsible also for sending emails, so let's also extract it. So we have email sender. It has, now it can accept any kinds of email messages. It doesn't know that it's gonna send report email messages. It will just accept the message. And we can use it for sending many different kinds of messages. Here we use the constructor not for dependency injection, not for defining and storing the dependencies, but here we store the address of an SMTP server and the address from which we will send the reports, the emails. And that's cool because we can use one instance of this email sender in the whole application, because we always always send emails from the same SMTP server. So we can use one instance and send many different kinds of emails from it. So at the end, we have email reporter, which is pretty simple. It has only 3 steps in the send report method. It is not responsible for any of them. We just pass them as a constructor, and we could send email reports with using different components. We can replace them and pass into the constructor. And it's really easy to read and to test. You can see just these 3 steps. You don't have to see the details. So we have split it into one long method into smaller classes. We have 3 data structures: user, report, and period, and 6 classes just for doing something. So we have more code, but the code is now structured. The objects have names, and they are reusable. So if you'd like to find the offers not only for reports, but maybe just display them on a web page, we can use the same offers finder. And if we change the way we find offers, we just change one place instead of changing the controller and sending reports and so on. Here's another code smell, too many methods in a class. It's the same example. It also is a user that sends reports, but instead of splitting it into classes, we have split it into separate methods. But it's for sure it's better to split into classes. Here you have a class, for example, for building a subject for an email message. As you can see, there's another code smell. We have a long name of a function: make, report, email, message, subject. We need these 3 words: report, email, and message, just for the context, because the user is not responsible for sending emails. So we have to define it in the method class. If we had just email preparator, we would have just make subject. Here's another code smell, too many indentation levels. As you can see, the deepest indentation here is 1, 2, 3, 4, 5, right? It's deeply indented. And we also have here some comment describing what the block of code below does. And the deepest indented code in here, it uses just one variable from the whole function. So if you'd like to test just this part of code, you would have to still open a file, you would have to iterate over some lines, and so on. But if you extracted this block of code into a separate function, then you could easily test it just passing it a line, right, and getting asserting the return value. And finally, we have a code smell. We have some functions, all of them doing the same thing, but they mix different languages in one code. So in the first example, we mix Python with HTML. We have an article controller which gets an article from database, and then it displays it as an HTML document. But it should not be responsible for how we build the HTML. We should have it in a separate layer, in a template probably. Another example, we have get the report from database also, and here it's better because we render a template, so we're not responsible for the HTML in this function, but we're mixing CSS with Python. because we're defining a CSS class for an article in Python. And now if we had a front-end developer which would like to change the name of a class, then he would have to touch the backend code. He should not touch the backend code. He's responsible just for front-end, right? And the last one, here we mix SQL with Python. We should instead have a separate function for getting the articles, like in the previous examples. Okay, so that's it. To summarize, we should split responsibility over classes, functions, and methods. Sometimes we have a responsibility which is actually should belong to the class, so we can move it into and it's on a lower level, we can move it to a private method, like in this example of preparing email messages. We had a separate method for preparing the email subject. It belongs to the class, but we can hide the details and pull the responsibility to the method. We should separate data structures from objects that do something. They should, instead of keeping the data in their attributes, they should accept the data as arguments. It's called DTO, Data Transfer Object. And finally, we can use dependency injection as to follow the dependency inversion principle, because we want our classes to be loosely coupled, and we don't want the classes to define the dependencies. We want to be able to define them on our own. Okay, so that's it. Thank you.
Thank you very much for your talk, Ignacy. So, are there any questions? Yep. Just hold on until the volunteer goes with the microphone.
Thanks. Great talk. I'd like to ask, what's a good practice for the CSS class thing? Because the CSS class, it can be a presentation thing, it can be a business logic thing. So how would you do the example with the CSS class?
I would probably pass a value of whether the article is new or not into the context, and then the front-end developer could use this variable just to define a class, CSS class.